Welcome to today's class. Today's class we want to or we'll be looking at logarithm part 1. Logarithm part 1. Okay. And please, if you are coming across my video for the first time, do well to click on the subscription button. So, logarithm part 1, we have laws of logarithm. Now, the first one we have is log AB base x is equal to log A base x plus log B base x. This law can also be called multiplication law of logarithm. And now, you can as well express the left hand side, or sorry, the right hand side is equal to the left hand side. It is still the same thing. So it's not in all cases that you see log AB base x being equal to this other side. You can write this other side is equal to this. It is still the same thing. Now, what that law says is that if I want to explain through this other side, when the bases are the same and it is addition, it can be expressed this way. That is A times B. Then you maintain the base since the bases are the same. The second one is what we call division law. As you can see, log A divided by B base x is equal to log A base x minus log B base x. Here the base is x, here the base is x, and it is subtraction. So when the bases are the same and it is subtraction, you can divide the numbers. That is why it is called division law. The next one, log A raised to power n base x is simply equal to the power, which is n, times the log of that number. So this is equal to n log A base x, the power times the log of that. And then this one is power in the base law. Here we have a power in the base. So log A base x raised to power n. When there is a power in the base, the answer is simply 1 over that power, then the log of that number. So log A base x raised to power n is simply equal to 1 over n log A base x. And then number 5, log of a number to the same base. Log of a number to the same base. Log A base A, the answer is 1. So when you have log of a number to the same base, for example, log 3 base 3, the answer is simply 1. Log of a number to the same base, the answer is 1. Then number 6, the logarithm of 1. The logarithm of 1 is equal to 0, whatever is the base. So if you have log 1 base 10, log 1 base 5, log 1 base 7, whatever base, as far as it is log 1, the answer is 0. So the logarithm of 1 is equal to 0. Then number 7, we have what we call change of base law. Change of base law. Now, this is log A base x. Assuming I want to change it to base n, a different base entirely. For example, if you look at this law 1, which you can call it multiplication law or you call it addition law, it is still the same thing. If you look at this law 1, this law works only when the bases are the same. If the bases are not the same, then you cannot apply this law. So there are cases that you may want to add or subtract 2 or 3 logarithms, and then their bases are not the same. So you can decide to change all of them to a particular base. That's what we mean by change of base. Here the base is x. If I want to change it to base n, it will simply be log A, the new base, all over log x, the new base. So if you want to change from this base x to, if you want to change from this base x to, let's say, base 3, it will now be log A, the new base, log x, the new base. That is what we call change of base. Now, we have relationship between indices and logarithms. If log n base A is equal to alpha, then A raised to power alpha is equal to n. Now let me explain that law. The logarithm of a number to any base, whatever it will give you as the answer, is simply the power to which the base must be raised to, so as to have that number. Let me explain it again in this side. I want to explain the relationship between logarithm and indices. the log of a number to any base, whatever it will give you as the answer is simply the power to which the base must be raised to, so as to have that number. So if log n base a is equal to alpha, it simply means the base raised to the power of that answer should give you n. That's the meaning. The log of a number to any base is simply the power to which the base must be raised to, so as to have n. That's why, for example, if you have log 100 base 10, the answer is simply, if you have log 100 base 10, the answer is simply 2. The reason is that 10 raised to power 2 is equal to 100. So the log of a number to any base, whatever it will give you as the answer, is simply the power to which the base must be raised to, so as to have that number. All right. So we call this logarithmic equation, and we call this index equation. We call this logarithmic equation, and we call this indexed equation, which simply means that for every logarithmic equation, there is a corresponding index equation. For every logarithmic equation, there is a corresponding index equation. For example, here, this is the logarithmic equation, while this is the index equation. So you can change from index to logarithm form. You can also change from logarithmic form to index form. Now we have just one example to consider in this video. We have one example to consider in this video. The question is, evaluate log 4/9 base 2/3. Now there are many ways of solving it. So looking at this, 4/9 can be written as 2/3 raised to the power of 2, because we know very well that 2 raised to the power 2 is 4, 3 raised to the power 2 is 9. So 4/9 is the same thing as that. And now base 2/3. Now remember, from one of the laws of logarithm, we have one of the laws. If you have log x raised to power n, let's say base a, the answer is simply n log x base a. So I will apply that law here. Log x raised to power n base a is simply equal to n log x base a. So applying that law, this will give me 2 log 2/3 base 2/3. And there's also another law that says log of a number to the same base. Log a base a, the answer is equal to 1. Log of a number to the same base. So if you look at this, log of this to the same base is simply equal to 1. So what we are having here is 2 times 1, and that is the answer. That's the answer. So with that, we have come to the end of this video, logarithm part 1. Thanks for watching. Bye for now.